Now the next thing that we have to understand is rhombus. Rhombus also is a parallelogram, and it is a parallelogram with equal sides. That's it. With equal sides. So what is important here is, if we draw a parallelogram and if we make sure that the adjacent sides are equal, then it will be called a rhombus. So if a side is A, then this side is also A, this side is also A, this side is also A. What will happen to the properties of rhombus? Very important. All properties of parallelogram. Remember, I am saying all properties of parallelogram, not of the rectangle. All properties of parallelogram will be applicable to the rhombus directly. What is extra? The extra property is very important here. Diagonals become perpendicular. Diagonals become perpendicular here. Okay. Now, what happens in the diagonals become perpendicular? The first thing that you can notice that all these four small triangles become congruent. That four small triangles become congruent. Right? What happened to the parallelogram and rhombus? Parallelogram and rectangle? In case of parallelogram and in case of rectangle, only the opposite triangles were congruent. Opposite triangles were congruent. That means this one and this one. In this case, all four are congruent. In case of rhombus, all four are congruent. Okay. Just to notice, areas are still equal. It's just that now they are, superimposable on one above the other. So all four small triangles are congruent. That is one thing. Secondly, here, can you draw a circumcircle passing through all four vertices? Not always, because that will be a specific situation. Not necessary, I'll say. Okay. In fact, it will be possible only if it becomes a square. But can you draw an incircle in a rhombus? Can you draw an incircle in a rhombus? Yes, definitely you can draw an incircle in a rhombus. What will be the center of that incircle? That will be the point of intersection of diagonals. What will be the length of radius? It will be half of the, so in radius of this, in radius that is R, will be half of the height. Right? Half of the height. You can see that. If I say this dotted line is the height, in radius will be half of the height. Okay. Now, before going ahead, I'll come back to this. But before going ahead with this, areas. What is the area of a parallelogram? Area of parallelogram is simply base into height. I'll just show. If I have this side as A, this side as B, okay, and if I drop this height, fine, say H1, and if I drop this height, say H2, then the area of this parallelogram is either A into H1 or it is also equal to B into H2. Okay, you can also see that the ratio of sides is opposite of ratio of heights. Right? This is for parallelogram. Then what about rectangle? Rectangle area is very simple. Length into breadth, that we have already seen, because it is 90-degree situation. This is L, this is B, so it is straight away L into B. Okay. What about rhombus area? Rhombus area will be simply equal to, a base is, here all the sides are same, so base is A into the height H. That's it. Fine. Now, there are multiple ways to look at it. There is another thing. Rhombus area is also given by half into D1 into D2. That is product of diagonals. Okay. Rhombus area is also like this. And in case of parallelogram, we have seen that D1 square plus D2 square is equal to 2 times A square plus B square. So in case of rhombus, can you see that D1 square plus D2 square will be equal to 2 times A square plus A square? So it is 4A square. Great. So there are many relations now, that is A is equal to, or 2A is equal to root of D1 square plus D2 square. A is equal to root of D1 square plus D2 square by 2. And if I replace here, h will be equal to d1 into d2 divided by 2a, that is for rhombus. So coming back to this, height of a rhombus is equal to product of diagonals divided by 2a. And 2a is this one, so height of rhombus can also be d1 into d2 product of diagonals divided by root of d1 square plus d2 square. Right? And from here you can also see that in radius now can be presented as half of height, that is h by 2, that is d1 into d2 divided by 2 times root of d1 square plus d2 square. Okay. Fine. So there are multiple ways of presenting this. So in radius can be calculated as half of the height. And if you know the height, you can present it either in terms of diagonals and sides or only the diagonals. Fine. Now we come to square. Now what is a square? Square is originally a parallelogram, right? In which all the angles are 90 degree and all the sides are equal. Oh, so basically it is a combination of rhombus and rectangle. Or in a way, can I simply say that all properties of parallelogram as well as rhombus, okay, as well as rectangle, all of them will be applicable to square. Oh, so there is no new property. For square, there is no extra property. Everything that we have seen for parallelogram, everything that we have seen for rhombus, rectangle, everything will be straight away applicable to square as it is. So area of a square, if I assume the sides to be a, it will be simply a square. Diagonal will be a root 2. Circumradius will be half of diagonal or a root 2 by 2, that is a by root 2. And in radius will be half of side, half of height, that is half of side. So it is simply a by 2. So this is all about all types of parallelograms, right?